Hello everyone, welcome back to NG Tutorials, and this is in the continuation of the previous year questions series. Today we are going to solve the questions of computer architecture and organization from December 2022 cycle. I hope you have watched all the previous videos. Keep liking the videos and you can comment down your queries if you have any. And if we talk about the December 2022 cycle, regarding the computer organization and architecture, there are questions, 5 to 6 questions only have been asked from this subject. So the weightage was from 12 to 15, including the digital logic questions also. So let's start solving the questions one by one. The first question is, which of the following types of memory is fastest? So to solve this question, first we have to have the knowledge of the memory hierarchy. So let's have a look at the memory hierarchy. And in this hierarchy, CPU registers are at the top. Then we have cache memory. Then we have main memory, magnetic disk, optical disk, and magnetic tape. So here, as we are going down, the capacity of these memories are increasing, as well as the access time, that means the speed is decreasing. Therefore, the CPU registers are the fastest, but they have the least storage capacity, and magnetic tapes are the slowest, but they have the largest storage capacity. So now let's answer this question, and it would be the register memory. Why? Because it is on the top of our memory hierarchies. They are the fastest of all. Students sometimes get confused between this cache and register. The cache is least faster than the registers, and the reason for this is that registers are inbuilt in the motherboard, in the CPU itself, whereas the cache is located externally in if we talk about the structure of our computer system. So register memory resides within the CPU and this resides externally. This is the reason. The next question is, the memory size for n address line and m data lines is given by. So this is the very standard formula that if we have n address line and m data lines, then the memory size would be defined by this 2 to the power n, that means 2 to the power address lines crossed by data lines. Next is, which of the following are true for dynamic RAM? So before solving this question, first we need to see the difference between static RAM and the dynamic RAM. Here is the difference, that the static RAM is the expensive, whereas the dynamic RAM is less expensive. This is faster as compared to the dynamic RAM, and this is the slower. This is having the low density, it is having the higher density. Static RAM needed less power, whereas dynamic RAM needed more power. Then if we talk about the capacity, static RAM is having the lower capacity and it is having the dynamic RAM is having the higher capacity. Volatile is our static RAM, whereas non-volatile is our dynamic RAM. That is, it does not need to refresh, whereas we have to refresh the static RAM. If we talk about their physical placement, so it is placed between the processor or a main memory, and it is placed in the motherboard itself. And data life, static RAM is having longer data life and dynamic RAM is having the shorter data life. So now let's solve the question we have. It is saying that it is slower than the static RAM. Yes, it is correct. Packing density is higher than static RAM. Yes, this is also correct. It is faster than static RAM. No. It requires data refreshing. Yes, we have seen that it is a volatile and it's need to refresh. So which option is matching? A, B and D. The first one. Next question is from the addressing modes, and if you have not watch the lecture of the addressing modes, please watch the lecture. There we have covered all the 14 types of addressing modes, which is very important if we talk about any examination of the computer science, including UGC NET also. And here we can see the example that 4 of the addressing modes are asked in this question itself. So every time there is one question definitely from this addressing modes topic. We will share the link in the description. You can just go and refer to that video if you have not covered this topic, because it is very important. So first is that direct addressing, which is the example of the direct addressing. What is direct addressing? The direct addressing is where we mention the data directly. So the third option, this one here, FFFH, that means store in the accumulator this value. Now 4 times F and H, this value we have to store in a accumulator. So this is your direct addressing mode. Indirect addressing mode is where we have specified with the any register location or any memory location for the operand value. So you can see that in the fourth option, move A to M. So M is your some memory location, there your data will be residing. We have to move that data to the A, register A. So this is your indirect addressing. Then we have the register addressing, where the operand resides in the registers. So option matching is this, move A to B. That means from register B we have to move the data to the A. Then immediate addressing, where the data is available immediately, MVI. We have to move this value in the register A, and MVI. So I stands for immediate addressing only. So which option is matching? A with the third, B with the 4, C with the 2, and D with the 1. This one third is correct option for this. So guys, if you don't understand this question, first you need to cover the addressing modes first, and then come to this question. You can find the link in the description. Now the question is, correct sequence and fetch execute cycle is. So this is from that fetch execution cycle. We have to tell them the correct sequence. So first we fetch the instruction, we decode the instruction, and then we execute it. So the correct option would be B, fetch, then A, decode, and then C. So B, A, C, fourth one. This is the correct one. Next is from the pipeline, which is the very important topic in if we consider UGC NET exam. They always ask questions from the pipelining. So this time they have asked the comparison of pipeline and unpipelined system. Consider an unpipelined machine with 10 nanosecond clock cycle, which uses 4 cycle for ALU operation and branches, whereas 5 cycle for memory operation. Assume that relative frequency of these operations are 40%, 20%, and 40% respectively due to clock skew and setup pipeline. Let us consider that the machine adds 1 nanosecond overhead. This is again an important information. 1 nanosecond overhead to the clock. How much speed up? This means that how speedy is the pipeline system if we compare it to the non-pipelined one, is observed in the instruction execution rate when a pipeline machine is considered. So first we will calculate for non-pipeline system, and then we will calculate the pipeline system time, and then we will compare it. So first let's convert this question into easier form. So we have given the operations, then we have given the frequency, and then we have given the clock cycles. Operation is ALU operation, and the frequency is 40%, and clock cycle is 4 clock cycles. Next we have is branch operation, which is taking 20% and 4 clock cycles. Next is memory, which is taking 40% frequency and 5 clock cycles. So the formula to calculate the total cycles is we have to first get it converted, this frequency percentage, to the number, and then we'll multiply it with the clock cycles. So here 0.40 multiplied by 4 plus 0.20 multiplied by 4 plus 0.40 multiplied by 5. Here we will get 1.6 plus 0.8 plus 2, and finally 4.4 clock cycles. So the non-pipeline time would be 4.4 into 10 nanosecond clock cycles. Here it is given, so we will multiply it with 10, so we will get 44. Then now we have to calculate the pipeline time. So in the pipeline time, we will only take this clock cycle, that is 10 nanosecond, and plus the overhead, which is the 1 second. 10 nanosecond, that is the clock cycle time, plus overhead. So it would be 10 plus 1, that is 11 is the time for your pipeline time. Now speed up would be non-pipelined divided by pipeline, that is 4, and this is the second option, that is 4 times. I hope this question is clear. So this is all about computer architecture and organization subject.